your name here. If you have it done early, let's say tomorrow, and you hand it to me, I'll gladly look over it over the weekend, give it back to you on Monday. That way you can fix it, whatever the problem may be, and get your perfect score on Tuesday. So if you have it done by tomorrow, I'm willing to look at it and let you fix it over the weekend. Because, let's face it, some people did not read the directions, and one of the problems asks you to get rid of the outlier. So if you did not physically go to your list and delete the point that was the outlier, you're in trouble. It should change your equation a little bit, one would think. It should change your R value a little bit, one would think. So if you're that person that made that mistake and you haven't caught it yet, maybe I will catch it and help let you fix it. Okay, in your notes, we're not even going to work the problems. If you would like, I'll probably work them and post a video tomorrow afternoon in case Jalea wants to see an example of this. But I really just need her to understand the vocab terms. So, goodness gracious. Okay, so when we left off the other day, we finished talking about like how to read the table. It was in your the calculator table if it was given. What parts are important, what parts weren't. And then after that, on the next page, it talks about extrapolation, which you didn't realize it, but you're already doing it. When you use that linear equation to predict something, you're extrapolating. So, and then of course, that prediction may or may not be accurate. What would help you decide how accurate your prediction was?
Calculate it.
What value lets you know, oh, this is a really good prediction? The R value. If you had over a 0.8 as the R value, you would know this is probably a really good prediction. But if you're between 0.5 and 0.8, it's a moderate prediction. If you're less than 0.5, it's probably a terrible prediction. Terrible, terrible. Okay, so a residual is, like we've discussed, if you've got some data and you've got a line match that data, what the residual is measuring is the difference between your estimated point and your for real point. It's estimating this difference in between. And you can calculate it by doing the obvious. What you actually got, you observed, minus what you predicted with your line, and that's going to give you the residual. And each data point has a residual. And some data points have a residual of 0 because some data points are directly on the line. So they are where they're supposed to be. Yes, dear?
Okay. Is the Y with the line over it, that's not Y bar, is it?
It is.
Okay. So Y hat has a different symbol?
Y hat looks like a little caret on top.
Okay, cool.
Like it looks like the exponent button in your calculator.
Like a little hat.
Yeah. So hence why I call it Y hat. Yeah.
Like
I don't know.
From the right steel.
Or the paper hat. I don't know. So when you're running a linear regression in your calculator, the residuals are actually already stored in a list, and the sum of all the residuals will always be 0. Because, okay, so for instance, this line, my 1 point that I did, isn't it positive above that purple expected line, whereas this point down here is negative and below. So that line that we placed is so good and fits so well that the difference between the positive people and the negative people ends up balancing out. So the sum of all the residuals is always 0. So the only reason I'm mentioning this is because, well, I mean, there are many reasons, but one thing is sum of residuals is always 0 is something that you're supposed to know.
I just opened the calculator and that was there.
What is it? That's funny.
Someone typed in kill me and hit enter and it said error and they repeated to do that 4 or 5 times.
That's funny. Okay, data points with negative residuals are below our expected value line. They're down here. They're below our line. If you have a positive residual, you're above our line. And then, since we're supposed to have a residual value of 0, and since our line is fitting so well, half our points should fall above our line, half our points should fall below. And if it was fitting like perfectly, then all our points would be directly on the line. Okay, so to truly test if your data has a linear pattern, you can look at a residual plot. You can make a residual plot. and you're like, how do I do that? You can calculate how far, again, we have a formula for it, and we can end up making our own plot, and I'll do a little video of that, of me doing that example that's in your thingy, in your notes, tomorrow afternoon. Okay, so basically, if our residual plot looks like, and with the residual plot, all it does is like points above 0, and we'd really like them all to be pretty much at, like, we would like for all our stuff to be directly at the bottom. I can show you how to make one. It's not a big deal. The other thing I want to talk about is what Shalia mentioned to me earlier, which is genius of her, because she's trying to get her worksheet done in advance. One of your questions asked about R squared. We've not really talked about R squared, except that it sure is useful to find R. So, how do you go from R squared to R? Okay, how do you go from R to R squared? Square it. It's really not that big of a deal. So you're like, I don't understand, why is R squared even a thing? So not only is it a thing, it even has its own vocab term. So a correlation coefficient means R. Coefficient of determination means R squared. The other day on your bouncy ball activity, since I was not here, I let you skip 2 problems. One of those 2 problems asked about the coefficient of determination, meaning it asked about R squared. So you could have done it all along if I had only written those words down somewhere. Okay, and then Shalia's like, but why do we give a rip about R squared? Like, why do we care? I thought we just needed it for R. And back to, I thought you said they just gave it to us to make us think, because if they give us R squared, we don't know whether or not R is positive or negative, so we have to figure out whether or not it's a positive or negative association. And she's completely right. However, with R, you only want a decimal, like 0.88. You don't actually get to say a percentage. You have to leave it as a decimal. With R, you have to leave it as a decimal. But with R squared, if you got, for instance, again, 0.88, you actually could say 88%. So R squared is useful when we're trying to, again, as is everything in this class, relate it back to the context. You can actually reference it as a percentage, and the exact sentence or the exact phrasing would be best if you said, like, 88% of the variation in, and then you have to insert your response variable, so maybe in lanes is accounted for by its linear relationship with Walmart customers, or whatever your 2 variables are. So basically 88% of the Y, so if we made this really algebraic, but it shouldn't be, it should be related to our terms within our problem. But basically 88% of the variation in Y is accounted for by X. But again, you're never actually going to say X, you're never actually going to say Y, you're actually going to throw in what those response and explanatory variables are in terms of your problem. So, for instance, with us, with those points and the wins, 88% of your wins is counted for by the number of points. So, really, R squared is not that useful. With Shalia, it seems stupid. R is the one that tells us how good our line is fitting the data. But R squared, when we're trying to relate this back to people in English, helps us do that because we can actually quote it as a percentage. Okay.
So R squared is just R, but a percent?
Yeah.
Why can't we just use R?
Well, R squared and percentage, yes. Say it again, Mackenzie.
Why can't we just use R and make it a percent? Like, I don't know. Why does it have to be squared?
R squared is the one we use to quote as a percentage. R, we only say how good it fits the line. Like 0.88 fits real good, 0.5 moderate, less than that, and weak. If you try to quote R as a percent, they're going to think you crazy and you don't know what you're doing. So again, R squared is the guy you can use if you're wanting to do a percent. And I think one of the questions on your worksheet asked you like to interpret R squared. And R is the one you're going to use to say how good your line's doing. Yes, dear?
So why is that? What's the reason behind that?
Oh, crap.
Yeah, like, that's what I understand which one is which, but.
Not a dumb question. Knew the answer 30 minutes ago. Forgot it now. Good thing I have a textbook. Okay, and then while I'm looking that up, the other last important thing I wanted to say to you was,
Oh, okay, I looked it up.
say it.
Because, like, when you do
God bless you for just Googling things instead of making me look in a textbook. Golly.
It's because when R is squared, you know, it makes a little square, literal square, because it's the distance between, you know, the x in the line, the y in the line. And so when it makes that square, that's actual measure, that's a measurable distance. So you can put that in a percentage.
Okay, and here, so back to what we were just looking at, Lee, in English hymn. We were just talking about the residual and how really R is measuring this residual, how well our line is fitting our data. But R is actually considering positive distance and negative distance, and that's why a residual plot should have a sum of all 0. But with R squared, a negative distance, since we're squaring everything, everybody's positive, so it's measured, this is a positive distance, this is a positive distance, and it actually measures the distance from all the points to the line. God bless you. I knew it was something easy, and I was just having a moment.
I looked up the over n minus 1. I didn't understand it. I looked it up, though. But
It's really weird, and you're like, okay, I'm just going to roll with it. That was my exact thought, was I'll just roll with it. But it's kind of like Levitas or any of the other calculus rules. You're like, I don't know who came up with this, but thank God it works. I'm going to always do this. That's how I felt about it. And then the last thing I was going to say, which is what we've discussed 1,000 times about outliers. So I had 3 things I was going to say. One was about residuals, one was about R squared, and the last is about outliers and influential points. So an outlier is, as you know, a point that's super far away. And we had a formula first chapter. What was the formula? We had a formula to calculate.
The Q3 plus 1.5 times IQR.
Yeah, we called it the 1.5 IQR rule. Yes. But that only worked with box plots and when we knew Q1 and Q3. We don't know what Q1, Q3, and anything like that now because we've got 2 variables. So we assume, the way Shalia assumed that 1 point was the outlier on your example with the Walmart or whatever it is you're doing. Like, we assume where they are, but really actually how to classify them with a scatter plot is points that have large residuals. They have large residuals. So, and which is kind of what Shalia's already doing with her eye. If the point is super far away from the line, then it's really a bad measure. It's going to have a large residual. So if it has large residual. So that's a good question. So, and it sounds really stupid, but with my blind eye, if something's nearby, I'm like, it's okay. But if someone's super far away, then I'm like, oh crap, no. And I feel like your worksheet was just like that.
That point over there is me, because it's bigger than us and it's far away.
Oh, well, that must be it. But like if it's super far away. Now, if there are quite a few over here, I'm not even sure I would say that is an outlier. Because in my mind, at this point, our line's really not doing a good job fitting the data. I bet the R value is super low anyway. So, Kinsey has a good question. How do we classify something as an outlier? That's a great question. My suggestion would be to find the R value with it. And then I would say find the R value without it. If your R value drastically changes, so you were at like a 0.7, now you're at a 0.77. So I would find my R value with it, and then I would remove it and find my R value again. And if your R value got higher, that point clearly was a problem. Now I'm saying drastically higher. 0.77 to 0.78, not a drastic change. But I'm saying a little, like, you felt like it was a big change. But as always, if Sally gets nervous and she doesn't want to pull the trigger and call something an outlier, because I get once you throw that word out there, you can't take it back. It's kind of like saying causes. You're not really sure you want to say it at all. You can always say something looks influential. That's our way of saying, I think it's an outlier, but I really don't know.
So I was asking yesterday about, like, if you had a calculator and, like, there's no way to do that.
Say it again.
Yesterday when I was writing the worksheet, I was like, so do I need a calculator? And you're like, oh, there's no way to do that. You know, just
Yes. So, well, there is a way to do it. You can see if it really, really changed your R value.
yeah.
But like a set formula the way we had that 1.5 IQR, no. Not really. I'm sure someone out there is trying to make one, but it's going to be super complicated. Jackson's got good eyes. If it looks super far away, take it out, see what happens. That's my 2 cents on that. I know that sounds the least mathematical thing I've ever said, but welcome to